So, let's move on to answering the question so that we can understand better what is the collisions and linear probing are. Suppose that the size of the hash table is 101. Further suppose that certain keys with the indices of 15s, 101, 1160 and 217 are to be inserted in this order into an initially empty hash table. Using modular arithmetic, find the indices in the hash table if linear probing is used. To visualize this question, we can simply imagine that there exists an empty hash table with the size of 101. The index start is 0 and end with 100. Initially, this hash table is empty and there are several keys that need to be inserted into this table, which are 15s, 101, 1160, 217. So, these keys need to be inserted into hash table. So, we need to find what are the key index for 15, what are the index for 101, 116, and so on. So, the question asks us to use modular arithmetic. Usually, the modular arithmetic is H, K equal to K, modulus and table size. H here stands for hash, K here stands for key, mod is modulus, and table size is what has been stated in the question, which are 101. So let's try to find the index for our keys. Just simply substitute the value into the expressions. So I have already substituted everything. So for key 15, 15 mod 101 is for us to find the remainder when 15 is divided with 101. Now, according to the modulus mathematical principle, if the number is smaller than the modulus, then the result is the number of itself. This means if the first number here is smaller than the second number here, so the result is the first number. So the remainder is 15. Meaning to say that the key 15 are going to be inserted into the index or slot 15 in the table. The next one is 101 modulus 101. 101 modulus 101 is 0. So no remainder. So simply just insert key 101 into index 0. And the next one is 116 modulus 101. It will give 15 as the remainder. How do I get 15? Just divide 116 with 101. And the remainder is the answer or the index itself. So, supposedly we need to insert key 116 at index 15. But notice here that our index 15 has been occupied by key 15s. So, this is what we call collisions, where two keys want to go to the same spot in the hash table. So, to solve this problem, we may use linear probing, where we can check the next slot, which is slot or index 16. If the slot is empty, we can insert our keys, and in this case, our slot 16 is not already yet occupied by any keys, so we can just insert key 116 into the slot. So this is what we call linear probing. Linear probing just looks at the next slot one by one until it finds an empty one. So the index for 116 is 16. 0 modulus 101 following the mathematical principles of modulus will give 0 back as the result. So we need to insert key 0 into index 0. But index 0 is already been occupied with key 101. So check the next slot. The next slot, which are in index 1, is empty. So just insert the key 0 into it. And the last key is 217. 217 modulus with 101 will return 15 as the remainder. How do I get 15? Just divide as usual, and the remainder here is the result of the modulus. So we need to insert 217 into index 15. Check the index 15 in the hash table again. It is not empty, so use linear probing. We can check the next slot one by one. Slot or index 16, does it empty? No, it is not empty. So what do? We check the next slot after 16, which is slot 17. Does it empty? Yes, so just insert 217 into it. So this is how we answer these questions, and this is what we call linear probing solutions. So our last answer is key 15 in index 15, key 101 in index 0, key 116 in index 16, and key 0 in index 1, and key 217 in index 17.